Recording begins. It is October 10th, 2025. This is ESM 105. Thank y'all for making it. Okay, we're here in week 7 of the semester. All right, so we really are getting, about at the halfway point. I wanted to just orient you to the course schedule. Remember, this is in the syllabus. You can check it anytime. We're going to be working on week 7 and 8 biodiversity slides this week, next week, and probably into week 9. Week 9, I'm just going to, if I teach this course again, it's going to be set up for catching up on previous materials. All right. Following week 9, we will enter a new topic of ecological economics, and quiz 4 will be available on November 2nd, which is going to cover the week 7 through 8 material. It'll be, clarified in the assignment description, just as the previous quizzes have been. Any questions about that? Cool. We got 3 quizzes left, and then there's a final. That final exam is going to be an online final. It'll be open during your regularly scheduled final exam time block, all right? And it's going to be a random selection of questions from the quizzes throughout the semester. Cool? Question?
Do you have an idea of the ratio of multiple choice to long answer questions for the final?
All multiple choice for the final. All right. So you've been doing your readings, responding to those readings. Awesome. The final's not going to have any of those essay questions. It's 50 points. Each one's going to be worth 2 points. It's going to be 25 multiple choice questions. You have the full block of time, which I think you are scheduled for an hour and 50 minutes for the final. So you get 2 hours to do 25 multiple choice questions. You got access to all your PowerPoints, all your notes that you could want, Yeah.
Wait, because I thought you said that the final was going to have questions from the readings, right? You changed your mind?
I changed my mind. Yeah.
Okay, cool. That's good. I'm happy about that.
Awesome. Yeah. I hope you've all been enjoying the readings, and all that. It's good assigned stuff. The department really wants every ESM student to have read those books. And so, I'm trying to find a way to assign them without making the final exam be like an 8-page essay report thing that honestly I don't want to grade. You know what I mean? Good stuff. Any other questions about that? So keep on doing those discussions, all right? Keep on chipping away at your annotated bibliography assignment and keep doing your quizzes, because those are all the places where points come from in this course, right? Okay. That's enough preamble. We can go ahead and get into the biodiversity PowerPoint. Oh, and let me shift the lights. Brace yourself if you're at the back. Okay, very good. So we've been talking about biodiversity. I've already kind of been laying out for you, how do we measure diversity? And that's come up quite a few times. All right, there will be a couple of questions on the quiz related to this PowerPoint that ask about measurements of species diversity. I clarify that in the assignment description, but just a heads up, there'll be some questions about that. You might want to reference the week 5 through 6 PowerPoint if you want to see additional materials there. Okay. So now we've talked about biodiversity. We've talked about some value of biodiversity. We talked about the diversity stability hypothesis and why it might have some problems, okay? But overall, we're usually concerned with maintaining biodiversity. So now what we're going to be doing is talking about different types of conservation and preservation efforts and how they can be used to maintain biodiversity. That's how I'm tying this in with biodiversity. So, some categories, right? When you're describing a conservation effort, sometimes that conservation effort is species-focused, where you're trying to conserve a certain species. Sometimes it is habitat-focused. There's going to be overlap here, because if you're trying to protect a given species, it's going to involve managing that species' habitat. Anyway, let's talk about how these plans sort of get generated and how they get framed. So we've got single species, multi-species approaches. If you're doing a species-focused conservation effort, you can focus on one species and maintaining its health. That makes a lot of sense if, say, you're talking about a keystone species. You focus your efforts on keeping that keystone species healthy and happy in the ecosystem, in the community, because it has such a large impact. All right. Multi-species approaches identify a few key species. They might not be keystone species, but a few key species, all right, that are necessary for healthy ecosystem functioning and aim to conserve all of them. A multi-species approach might not require as much of an understanding of each species' requirements. You can make a broader plan because you're framing it as we are attempting to conserve these 12 essential species. So there's going to be more leeway in making the plan a little bit broader. You can also draft a plan as being habitat focused. All right. So there are endangered habitat types. Classification of habitat types is a whole thing. It's separate from biomes, but it's similar principles, okay? Except that the requirements for defining a habitat type tend to be more involved and nuanced. Like, oh, at least 10% of the plant community must be made up of this type of plant, and 15% must be made up of this type of plant, and there must be less than this amount of precipitation, and greater than this amount of different soil types, right? Anyway, a habitat-focused plan is aimed at maintaining a specific habitat type, and as I said, defining habitat types is its own specialty, right? There's frameworks for it, though. These are all laid out. Endangered habitats can be protected in a very similar way to protecting endangered species. You say this habitat type cannot be developed, and we're going to, set it aside. Very good. So habitats themselves may be endangered or perform ecosystem services. Solid. Great. So it's easy to think about if you're thinking about the bogs. Bogs are a very specific habitat type. They define in a very specific way, and they carry out ecosystem services such as carbon sequestration, water filtration, as well as providing essential habitats for some species that can't exist in other habitat types. Fair enough? It's all about how you're framing it. So species-focused or habitat-focused conservation projects. Okay. What are our threats to biodiversity? Well, extinction lowers biodiversity. What is extinction? Extinction is when a species is entirely removed from the planet. And I'll talk about some different sort of degrees of extinction. Right? Extinction is very specific. It's the most extreme. The species no longer exists. But there's also things like an extirpation event, which is a localized extinction event, where a species may be present in other regions, but it's no longer present here. All right? Standard issue, this is basically standard issue boilerplate ecology text on the board right here about natural extinction. All right? Most ecology textbooks have something very, very similar to this. The majority of species that have existed have gone extinct. Extinction's a natural trend, all right? And if you think about it as, a species speciates and splits into two new species, well, the reason that it could do that is because there's some selective pressure that's causing one population to evolve differently within that species. So if that pressure makes this new species emerge, it might also make this species that has a lot of those ancestral characteristics go extinct. So it's a process of change, and natural background extinction rates are normal, they're happening. There are mass extinction events in history that have occurred, okay? There's, the big extinction event that had to do with atmospheric composition changes. There's the end of the Cretaceous period, a mass extinction event involved with changes to light levels and other things as well. Differences in atmospheric composition as well as differences in light availability. Classic mass extinction events that were not human-caused in any way. And now what we're saying is that humans have accelerated the natural background extinction rate rapidly. It's been drastically increased. So species are going extinct more rapidly. Usually it's due to habitat destruction, all right? Habitat destruction, shrinking of habitats, fragmentation of what was a continuous habitat. So you try to understand what's increasing the extinction rates and then carry out conservation projects to mitigate those factors that are increasing extinction rates. Reasonable enough? All right. So yeah, main big threat to biodiversity is extinction, and extinction rates are accelerating due to human activity. Pretty boilerplate. Let's get some terminology out there. It's always nice to have new terminology. More nuanced vocabulary lets you discuss things in more detail, and it's great. It's good stuff. So extinction is completely gone. The species is gone. There are no more individuals. Okay? There's also functional extinction here at the bottom, where the species still has individuals present, but maybe all of the individuals are male. And so functionally, the species is extinct. There's not going to be any replacement. Or maybe genetic diversity is so low that that all of the offspring are non-viable. Okay? Now, can you combat this maybe with modern genetic techniques? Is possible. Okay? But that's quite a challenge. Good stuff. Extinction on the entire biosphere, on the entire globe. Extirpation, localized extinction. All right? If the species is extinct in the wild, it still exists, all right, but only in captivity or in what we would call ex situ conservation, which is a fancy way of saying we took the animal out of where it lives to a new site, ex situ, and now we're just giving it what it needs to keep it alive. All right? So we will talk about in situ conservation versus ex situ conservation, and those are general terms that mean in sight or out of sight. So, in situ things happen in their natural habitat. Ex situ projects remove the individuals from that natural habitat. So a lot of those in situ conservation projects are going to be habitat management projects, habitat-focused projects. Cool? All right. How many species are there? What percentage of those species are threatened? Okay. Part of that comes down to how many of those species have been evaluated. So if we estimate that there are 1 million different species of insects, okay, about 1% have been evaluated for whether they are endangered or threatened species, because threatened actually has, the term endangered, the term threatened, they have definitions assigned to them. So what we've got here on this table is the estimated number of individuals, what percentage of those individuals have been evaluated. Mammals have the highest here at 91%. They claim that 100% of bird species have been evaluated in this table. This all comes from the IUCN, the International Union for the Conservation of Nature, and we're going to talk about them for a little bit today because it's an interesting group that's basically got a monopoly on determining if species are endangered or not, which is kind of wild. It's a non-government organization, it's global, it's international. Moving on, some plant species, fungi. See the table, how it works. Really, I put these up here to just show you, I want to get you thinking about, well, who's doing this evaluation and who's reporting this data, okay? Because that's important if you're drafting these regulations. So all of this data comes from the IUCN Red List. And you might have heard of the Red List. The Red List is basically just a big list of species that are endangered or at risk of extinction. It also includes species that are at different levels, experiencing different levels of threat. So it'll say, oh, these are low concern species. These are vulnerable species. These are almost threatened species. A species can become endangered, critically endangered, extinct in the wild, or extinct. There's a whole spectrum defined by the IUCN, and they assign these terms to different species. And then that's used by agencies to determine when it is prudent to use or implement a conservation plan. So we might want to know a little bit about what's the IUCN, the International Union for Conservation of Nature. So the World Wildlife Fund, you've seen this panda before, all right? It's a famous panda. It was established by the IUCN, this group, in order to raise funds for the IUCN's operations. This is a great example of what we would call a flagship species, where they use imagery of a panda, even though the WWF's not necessarily engaged in panda conservation at all. They're using it to get, positive attention and to get people to say, oh yeah, I'll donate money to the World Wildlife Fund. I love pandas. We'll talk about flagship species in a little bit, all right, which we define as charismatic species that are used to garner attention and support for conservation efforts. All right. So the IUCN is a very interesting rabbit hole to go down. It was founded in 1948. Their whole goal, as they established, was to determine which species are at risk of extinction and which habitats are at risk, and provide information to governments and to other agencies and to corporations, whoever wants the information, about where these at-risk species are. All right? It really is a fun rabbit hole to go down. Like one of the main founding members was Aldous Huxley's brother, which is weird. And if you want to go down another fun rabbit hole, just look at the Huxley family. It's super strange. Because Aldous Huxley, he wrote Brave New World, Doors of Perception. It's like required college reading outside of your classes. He also was a big old celebrity back when you could be a huge celebrity for writing books like that. Okay? And he, at one point, was in a relationship with the then equivalent of basically like Paris Hilton, of a lady who was famous for being rich and was part of a big money family. And they were seen out on the town. And if you've seen a picture of Aldous Huxley, he's an odd-looking fella. But yeah. Anyways, his brother helped to found this. Their dad was an established scientist. All right? And anyways, it's very fascinating. The IUCN falls under criticism sometimes for their practices. The organization has grown, it is massive now, and the IUCN Red List is the main source that anybody uses for determining, are there endangered species here? So as you can imagine, you get into some interesting dealings when you're an organization of that size. Okay, very cool. So sometimes they'll do things like support the establishment of a nature preserve where people live, and then say we can't have people there, they're threatening these endangered species. We have to get those people out of here. They're not allowed to live here anymore. As happened with the Maasai people in Africa. All right, it's pretty interesting. There's also some cooperation with corporate interests that has fallen under scrutiny with companies like Coca-Cola, okay? We'll talk really quickly about Eco Center as an example of greenwashing facilitated by the IUCN. Now, my goal here is not to say the IUCN is an evil, greedy group of people, all right? Just trying to get money and remove indigenous peoples, but rather to show that an organization of this size that has so much sway, there's going to be variability in how it operates. So, great. They're involved in this creation of this CITES program. They make all these agreements. They draft these agreements that are optional. Countries sign on to them, and they'll agree, like, we're not going to allow the trade of endangered species. That's like the CITES agreement, which is a huge, really important one. You can't transport an endangered species across state lines or between countries, or you face pretty aggressive penalties. And that agreement was drafted by the IUCN. And now countries adhere to that. So, that's another thing to think about. Anyways, compliance with the rules is not usually legally binding because they are not a government organization or agency. There's this other group that they have worked with called the World Business Council for Sustainable Development, which we will talk a little bit about when we get into our ecological economics section, because this is a group of people who are trying to maintain business activities. That's kind of their main goal, is keep business moving forward, keep developing, but they also are trying to maintain ecological stability, at least on paper. Oh, it'll be fun to talk about. So why is IUCN so important? Why is it coming up? Why am I mentioning it so much here? Because of this, right here, the red list. It's always referenced. People will just say, oh, that species is on the red list. And people will know what it means. As you move on in your conservation program, you're going to hear the IUCN red list referenced constantly. And I hope that now maybe you've got a little information about the IUCN. And one example of a deal that they have worked with these different companies to set up these things called eco centers, which maybe you've heard of. They're really strange. They're like these little kiosks that are solar powered now, and they are set up in developing countries. They provide clean water, and they promote that they also provide employment opportunities. All right? So you hire people who live in the area to run these little eco centers, which are designed to provide clean water. And you'll see some of the companies involved in this include IBM and Coca-Cola. If you look at the eco center, it's got like Coca-Cola colors. It's really a weird thing, okay? And there's things to consider here. This could be considered an example of what we call greenwashing, where a company will try to improve its public image, all right, by carrying out some sort of conservation effort. And then the impact of these efforts isn't always tracked very aggressively. I tried to do a bit of a dive and find how many jobs has this created, and how much clean water have these eco centers provided, and what's the shutdown rate of these eco centers, and who's getting paid to build these eco centers. Recently, they entered into an agreement with a solar panel manufacturer to provide solar panels for all of these, which was not in the original designs of the eco centers. So now that solar panel manufacturing company has a huge contract to put solar panels on all these eco centers. Something to think about. But don't worry, folks, because at the end of the day, Coca-Cola does have your best interests at heart. So you can see this quote right here that came from an official analysis document circulated within Coca-Cola, which basically just says, hey, if we run out of water, we're not going to be able to make money, and we need water in Coca-Cola. All right. Now, if that works out for us, if Coca-Cola's like, we got to keep water clean, and that keeps our water clean, I'm cool with it. I want clean water, Anyways, I don't need to bang you over the head with this too much, I don't think, but it's just an example of how an organization established for philanthropic reasons, as it grows and grows and grows and gets more interest and its data is used more and more often, eyes get turned on it and money starts to move towards it. All right. Okay. Oh, I zoom in on it. Whoa. Fun. I put a little animation in there. UPS. Thank you, UPS. All right. Anyway, let's move off of that weird. When I was preparing for this course overall, I started to go down that, and I got my little, I got my tinfoil hat on, and I was like, the eco centers, they're going to be everywhere. but it just happens. Let's keep moving forward. So check this out. E.O. Wilson, you read an E.O. Wilson book, all right? E.O. Wilson is credited with developing a cute little acronym of HIPPO, all right? HIPPO for habitat destruction, invasive species, pollution, population, and overharvesting, the threats to wildlife. We're going to talk about HI in this PowerPoint, and then in a future PowerPoint, we'll talk about POPO, all right? Cool. So habitat destruction, as I've mentioned, considered the biggest current threat to biodiversity, or the biggest human-caused, the largest human-caused factor in increased extinction rates. Tear a habitat apart, fragment that habitat. So we need to talk about what makes a habitat stable, what makes a habitat unstable. The key point that we're going to talk about is habitat fragmentation, because it's not that human activity takes a full habitat and just, always clean sweeps everything out of there and just pulls all the resources out and leaves bare earth. It's oftentimes that humans will take from a small region of that larger habitat, all right? And then from this small region of that larger habitat, and this small region of that larger habitat, all right? And you generate what's called a fragmented habitat, where you split up a larger area into smaller areas. So if you talk to habitat or landscape ecologists, or what they're called, ecologists who study the effect of the landscape on the ecosystem function, the things like the continuity of habitats, they will usually say, or in their textbooks at least, they'll write that habitat fragmentation is the biggest threat, instead of whole-scale habitat destruction, which is actually usually rarer. Okay? Anyways, habitat destruction. What do humans do to destroy habitats? Well, we convert forests to farmlands, forests to cities. Habitat gets fragmented. Habitat can be fragmented by something as simple as building a big highway through it, Dams, mining, destructive fishing practices. All of these can destroy habitats. From the biomes discussion how important substrate stability is in determining marine biomes. Well, nets, fishing practices that just scrape the bottom of the ocean, right? That's going to destroy the substrate and kill the things living in it and disrupt everything and change the substrate stability. And it can cause a whole biome shift. So that's an example of a destructive fishing practice, even though we usually think of a destructive fishing practice as like an excessive take, like you take too many fish out. Also, practices can destroy the habitat itself. All right, so the I in HIPPO is invasive species. Human activity moves things around the globe. Things get shipped, things get moved within a country, things get moved between countries, across oceans. There's all sorts of things that transport invasive species. So what used to be an impassable barrier for a species becomes a very passable barrier if you're in the storage of a big ship, right? Now you just get transported. So humans can serve as vectors for invasive species. Remember, there's a background extinction rate. Invasive species are a natural thing. They happen. Sometimes they become dominant in an ecosystem, and it doesn't have to be a bad thing. But what we're talking about here are specifically human threats to wildlife, all right? So human-mediated vectoring of invasive species. Cool? Most of the time, you take a species, you introduce it into a new habitat, and it just dies. It doesn't become invasive. All right, we'll talk about the different terminology about invasive species, maybe in the next slide. Yeah, look at that. All right. So there's different terminology for invasive species. Ready for some different terminology? Sound good? All right. So do I have my thing about exotic? I don't have a thing about exotic. That's okay. So there's also this term exotic species. An exotic species just didn't used to be there. All right. It's not necessarily invasive. An invasive species is specifically capable of sustaining its population and growing its population. All right? So check this out. You take a species from one place, you move it to another. Maybe it's in ballast water of a ship, you dump that ballast water out of the ship, and you just introduce all these little marine species. Right now, they're introduced. You have introduced them. They weren't in this habitat before, and now they are in this habitat. I'm going to talk about it. We have week 9 for catching up on material. The species wasn't here before, or the species is new to the area. If I say those things, you have an idea of what I mean. And maybe you don't even worry about it, you don't really think about it, you just go like, okay, yeah, it's an introduced species, it wasn't there before. What determines if the species was originally there? Okay? Because that really matters if you're doing conservation that's aimed at controlling invasive species. You have to be able to define, is the species invasive? All right? So there are sort of 2 competing theories, which I removed. I was going to put slides in about it, but I removed them because I just had too much stuff coming at you. But now I decided I want to talk about it. All right, here we go. There's 2 main points in time that people point to as, this is when we're going to say the species was native. Okay? One is the last glacial maximum, when there's the last time when the glaciers were as big as they ever were, because there was more interconnectedness between areas of land. So at that last glacial maximum, there was maximum connectivity between patches of land, right? There were ice bridges that existed. The sea levels were lower because more ice, more water was tied up in the glaciers. And so there were exposed land bridges. So the world was more interconnected. So some people will say anything that was there at that point in time, all right, is a native species. Some people use a different time point. I'm blanking on the year, which is so embarrassing. I'm blanking on the year, but the point is that the other time point used is when global trade began. So once global trade begins, some people say, well, anything that was here before global trade became a serious pressure, well, those are the native species. And we're only concerned about invasive species that are vectored by humans. You see what I mean? So it does matter how you define if a species is invasive or not. Was it here 1,000 years ago? And it hasn't been here for 1,000 years, and now it's getting reintroduced? Is it invasive now? That's going to depend on who you talk to. Okay, so check this out. You take a species, you introduce it. It's got this period where 90% of those things are going to just perish and die. They're in a new habitat. They're not adapted to the predators there, the competitors there. They're not adapted to the abiotic conditions. They just die, okay? But a species that's going to persist undergoes a period of phenotypic plasticity, all right? Where the individuals begin to acclimate, all right? So the individuals that are there, they aren't necessarily undergoing natural selection, but they are undergoing natural selection, but they're not necessarily evolving their allele frequencies. Rather, the individuals are undergoing phenotypic plasticity, changing their expression of their genetics. So there's this little waiting period where the population grows very slowly as the individuals acclimate. Once the species has acclimated, okay, we call it naturalized, all right? Now it's become naturalized to its environment, and it's no longer reliant on repeated reintroductions. So a naturalized species can now continue to reproduce and provide its own, provide all the individuals that it needs to maintain a population there. And once you have that, you've got an isolated gene pool that can really start to undergo natural selection. So oftentimes, an introduced species population is only there because it's constantly being introduced. And it's not actually adapted yet, or it's not acclimated yet, so it's not naturalized. Once it's naturalized and reproducing and it's a self-sustaining population, now that population can undergo a period of local adaptation, where that population, it undergoes natural selection and becomes better adapted genetically to its new environment. So there's usually this little lag period here in the growth of the population of an invasive species, where it is undergoing local adaptation. And once the genetics have been selected and that little population has good genes for that area, then it can truly become invasive, where it starts to rapidly increase its population size. All right, now it has a good arsenal of genes here. And once the population has become naturalized and on local adaptation, and the population starts to spike and go up more rapidly, it can start to spread to surrounding areas. Because if you're adapted to this habitat here, and you have many offspring that you're making, then some offspring leave. And they go into other areas, and then they get introduced there. And then they become naturalized there. And then they undergo a period of local adaptation there. And then the range of that invasive species just spreads. All right? Oh. I put in all these nice animations and didn't use any of them. Okay, cool. So phenotypic plasticity period, go becoming naturalized. Then we've got selection and leading to local adaptation, makes the phenotype move closer to the optimum for the novel habitat. And then the species becomes truly invasive, and it can start to spread. Solid? Okay. Not to memorize, though I do have questions on your quiz about these, the characteristics of species that make them better at being invasive, and the characteristics of habitats, which is coming up. Yeah, and the characteristics of habitats, which put them at greater risk for invasive species. All right? You can reference the PowerPoint where you're doing the quiz and look up on these tables. So we're going to talk about a few of these things, but I don't want you to you don't need to memorize this entire table. See what I'm saying? It's not even a table, this big bullet point list. Okay. What makes a species good at being invasive? Well, if it reproduces a bunch, that makes it good at being invasive. That's high fecundity, okay? Usually small species are better at being invasive, all right? If it can carry out asexual reproduction, it's usually better at being invasive because it can make more individuals. If it has a lot of genetic diversity, that's useful. High phenotypic plasticity, that helps. If it has a broad native range, that means that that species has the capacity to inhabit a lot of different habitat types, right? So it either has high phenotypic plasticity, or there's a lot of genetic diversity in that species, or it's had other characteristics that have allowed it to spread. And a spreading species is an invasive species. If it's very abundant in its native range, if it has a lot of tolerances to abiotic conditions, if it's a habitat generalist, that means it can inhabit a bunch of different habitat types. If it's a human commensal, so if it provides some benefit to humans, all right, or if humans provide some one-sided benefit to it, all right, then that's, beneficial for it. Good, let's see, I've got, boom. One big one here is a loss of natural enemies. That makes a species more likely to become invasive. If there's one thing that really suppresses a species population, and then you move it to a new habitat where that predator that's consuming it isn't there anymore, well then it's going to be able to explode in its population size maybe more rapidly than predators in the new habitat can adapt to consuming it. Because it's a food source now, but does anything eat it, And this is a major problem if you've got, say, a chemical defense. Imagine a frog that's poisonous, and there's snakes that eat it in its native range, And those snakes and it are on a constant biological arms race where the snakes are adapting to tolerate the poison, and the frogs are getting more and more, a higher and higher concentration of the poison in their tissues. Now you take that poisonous frog, you move it to a new habitat, and the snakes there didn't ever undergo that selective pressure, so they've got no resistance to the poison. But the poison levels are really high in the frogs. All right? Now, over time, that might even out, but that's a real world example with snakes and frogs that happened in, I think, Florida. Anyways. Next we've got, come on. Come on. It's trying. Do the invasion meltdown. It's the hot new dance craze. Oh my gosh, it's so annoying. Okay, so invasion meltdown, I put in parentheses, it's a snowball effect, all right? Sometimes one invasive species can bring another invasive species along with it or facilitate the establishment of another invasive species by changing the environment a little bit. Polyphagy, phage relates to eating. Poly means many, so polyphagy is you eat a lot of stuff. Many eating. So if you can eat many things, then you get into the new habitat, you'll eat something. You'll find some food source. Okay. Now, the big disclaimer statement, right? That sometimes evidence doesn't always hold for this. Like, not every individual that is small is going to be an invasive species, and not every individual with high fecundity is going to be very good at being an invasive species. But these are some general characteristics. And if you remember our R versus K selected species when we were talking about life histories, you'd see a ton of overlap between the characteristics for invasion success and the R selected species. Things like high fecundity, small size, etc. Okay, now what makes a habitat likely to be invaded? Well, if it is climatically matched to the site of origin for the invasive species doesn't have to deal with changing abiotic factors. So that's beneficial. A habitat with a high rate of disturbance tends to be, more prone to invasive species establishment, because disturbances open up resources. And species that have adapted to become invasive, like colonizing species, right, they capitalize on these disturbances. So a highly disturbed habitat, or a habitat that's not disturbed in a healthy way, where the disturbance is drastic and it happens, long periods of time between those disturbances, it's likely that it could be invaded. All right. Habitat with low diversity is usually considered as one that's under threat for invasion success. But remember our diversity stability hypothesis, right? While this tends to hold, it does not always hold. Okay, there's no predators, there's a bunch of vacant niches. That all makes sense, I hope, intuitively. If it's very nutrient rich, invasive species could do really well. If there are, here we go. If we have a low connectance of the food web. All right, I showed you a slide about food web connectance. Basically, if there's a lot of connections between the different species in a community, where one species is eating a bunch of different things and the species are consumed by a bunch of different things, high connectance might be a better indicator of stability than actually looking at the diversity of the community there, the diversity of individuals on the habitat. And connectance is just measured as the proportion of possible links that are actually realized. So, you've got these different species. There are all these potential links that could be realized between all these individuals, right? I already drew that one. I'm sure I missed some. But anyways, there's all these potential links that could be realized by the individuals. And if only a couple of these are actually realized links, then that indicates a low connectance level. All right? Higher connectance means that if something goes down a little bit, it's going to have more of an impact. It's more stabilizing. Cool. Connectivity. Connectivity is different from connectance of a food web. Connectivity means are habitat patches linked to one another, right? So if there's a river that's running through an area and an invasive species establishes up here, then, and it can be vectored through the water, well, then it's going to just pop up all along the riverbanks, all right? So that's what we'd say is, that's what we would call a habitat with high connectivity. Or even if you have a bunch of these fragmented habitat patches, but you've connected them with wildlife corridors, or am I doing it on the board, on the table that you can't see? If you have a fragmented habitat that has all these different like habitat patches, and in an attempt to carry out some conservation or management practices, you've connected them all with wildlife corridors, which are linear features of the same habitat type. Well, when you do this, you've increased the connectivity of the habitat, and that's beneficial for the native species there, but it's also beneficial for the invasive species there, right? Because they can go here, grow, become strong, and then move through those linear features in the same way that the native species that you intended to help can move through those linear features. All right, solid. And we'll come back on what would it be, Monday, and talk about are all non-invasive species bad? And the spoiler alert is no, not all invasive species or non-native species are bad. But when we call them invasive, we usually imply that they're bad. Anyways, we'll talk about that on Monday. Sorry, I went a minute over. I apologize genuinely, and I hope you have a wonderful weekend. All right, cool.